Okay, so inverse functions. So the first way you can find an inverse function is to switch the x and y values, okay? So this is saying it for a relation, which is just a straight line, a function that's a straight line, but this also works for every single type of function we will work with, okay? So whenever you're doing the inverse, a really simple way is if it gives you the x and y coordinate. So we can say our x value is 2 and our y value is -3. If we were finding its inverse, you are simply going to just switch them, okay? Now you're not going to change anything with the signs. You're literally going to just switch places. So if my x was 2, then if I were to find the inverse, the y would become 2. And if my y was -3, then my x becomes -3. They literally just switch, okay? And you're going to see that better reflected graphically, but it really helps if you understand it with its coordinates. So here's some examples. So I opened up my little packet and I'm looking at this top section here. Okay, so we're just going to practice that a couple of times. And it is simply as easy as it looks. Did you check Kirsten's room?
Not yet. I just can't be listed here
Um,
because nobody's in a room.
Go check Kirsten's room and I'll text her and see where she's at.
Wow. Not cool, bro. Not cool.
Chloe, those glasses are really nice. Really cool.
No, not this one.
Chloe's glasses. Her shoes are tied, don't worry.
All right, here we go. So we have our coordinates and we're going to find the inverse. So these are all the coordinates of the original function. Okay, so we can just imagine those being graphed. So now we're going to find the inverse. So I'm going to start off by drawing my little bracket. Okay, so if my original coordinate was 3, 4, what would its inverse be?
4, 3.
4, 3.
2 universe. I draw backwards to the bracket.
All right, perfect. If my original coordinate was 1, -2, my inverse coordinate would be -2, 1.
Yeah, switch all of them.
Okay, and then if my original coordinate was 5 or -5, -1, my inverse would be -1, -5.
So, what
Okay.
is the point in that inverse?
This is if you were taking like a real world situation and like we did at the beginning of the year, we would create an equation for that real world situation. Okay, well, this is if you were taking that and then solving it for the other variable. Okay, and not just in representing it graphically. Okay, which can be done with, we know it in basic like equations, but like as we move forward, we're going to get into more complicated functions. Like here on this, you can see it kind of represented on this calculator. Like we're going to be getting into more complicated functions. So it's easier to understand it this way than we'll get into more real world application, but this is just the basic of how to find it.
How will we use this?
We'll get to that. Okay, right now I'm just teaching you what an inverse function is. Okay, but short term, real world test, ACT, Algebra 2. So there's your real world if it's short term. Okay, so if we had these original coordinates, what would my inverse of 0, -2 be? -2, 0. All right, what would my inverse of -1, 4 be? Or -1.
Whoa, now this one.
Okay, now if we had -2, -2,
Pretty much
It would-
stay the same.
it would just stay the same. And we're going to see what that looks like graphically here in just a second.
Actually, would switch. Because you
No,
still have to
no.
do it.
But it's still the same.
It
All
looks
right,
the same, but
so
it's-
sometimes, and what we're going to learn as we move through all these functions and stuff and like learning all these different rules, your best friend in algebra is going to become these little tables. Okay, because there's a lot of rules that you can learn about functions, but sometimes we forget the rules, but we can always remember how one of these tables works. So And we'll practice that here in a second. So sometimes your coordinates are going to be represented by a table. So we're going to just say this is our original function. Okay. So our original one, our x is -2 and our y is -3. So its inverse is going to be -3, -2. Yes, sir.
You know how like original and origin is spelled like, it's ORI, but in origin, it's ORGIN.
No.
That's origin.
That's what I said, origin.
No, that'd be
Oregon.
Oregon. That'd be Oregon.
The organ's with the A.
No, but it's ORGAN. Origin is ORIGIN.
Oh.
Yeah.
Never mind.
Next, we
That's why I shouldn't have worked there.
okay. Now we have 1 0. So what?
0, 1,
0 1 4 3
3, 4.
3 4. Okay, so that is like basic, easy stuff, which is going to come in handy when we get to more complicated functions. Is just understanding that. But sometimes you're not going to be given the coordinates, or you're not going to be given a table. So another way you can find the inverse is by looking at its graph. Okay, so turn back, fold your paper back, and we're going to be looking at how to find the inverse using a graph. Okay, so this line that they've drawn here is a function. Okay, so we're going to be taking this line and we're going to be finding its inverse. Okay, so in order to do that, they didn't give us any coordinates, so we're going to have to find the coordinates ourselves. So if you're looking at this line, do you see any coordinates that the line is perfectly going through?
Yes.
Okay, give me one of them.
3,
3 2. Okay, so I'm graphing that point.
Wait, what was the question?
Any coordinates that the line is perfectly going through. And 0 3. Those are the only two it's perfectly going through. Okay. So I'm going to label this table f of x because that's what we know we call just original functions. Okay, so let's label those points. Let's start from left to right. Okay, so the first one we said was 0 3. All right, and then the second one was 2 3. Wait, dang it, I did that last time. 3 2.
Wow.
Technically, you get it right on the other side.
Did.
Yeah, let him try.
All right, now we're going to be talking about the inverse, but they didn't label it inverse. And I'm going to show you when you are looking at a math problem and it wants you to find the inverse, it's not going to say inverse. It's actually going to be written like this. And you may have seen this before on your STAR test, or you might have saw it on the ACT Aspire, but it looks like this. Okay, it's this little symbol right here. So it's very similar to a function. It still looks like a function, but they've added this little -1 up here as like an exponent. Okay, that just simply means inverse. So if you ever see that symbol, that is what it means. Okay, and you would just read it as f of -1 of x.
F of -1 of x.
Correct.
Nice.
Okay, so if our original coordinate was 0 3, what is its inverse? 3 0. If our original coordinate was 3 2, what is its inverse? 2 3. Okay, so now let's see what that looks like graphically, because something about inverse functions is there's one thing that every single inverse function you ever do will always have in common. Okay, so let's graph these points. So I'm going to go to 3 0 and I'm going to graph it. Okay, and then I'm going to go to 2 3 over 2 up 3, and I'm going to graph that and I'm going to connect them.
That's nothing like the other. Yeah.
Okay, and then I'm just going to draw me a little straight line.
I'll press this one.
Draw it a little thicker so I can see it.
So I meant like a right turn degree angle.
Okay,
Great.
so I want y'all to look at that. So let's say I want y'all to know, like when y'all looking back, this one is the green line is my inverse. Oh my gosh.
Frisbee the other day. I had 2 double quarter pounders from McDonald's.
That's weak.
Bad.
How on
It's
earth?
1,000 throw
One second, I gotta get an $8.
That's really weak.
What do you
Have you seen me do?
3 Big Mac. What do you eat?
All right,
Bar.
so there is my inverse in my original function is this pink line, okay? Stay with me here. Okay, so what do we notice is happening? They are intersecting, okay? But one thing I want y'all to understand is that is not what every single inverse function has in common, okay? That will happen on the 2 we look at today, but that's not the big takeaway I want y'all to understand, okay?
It's like that thing we did in 8th grade when there was like angles and like the triangles and stuff.
And you moved them across the graph.
Yeah.
That's exactly what's happening. Okay.
Whoa.
Yes,
We can
good.
make
Oh, we did
Okay.
that in there.
It's not actually called a transition. This is actually would be a reflection.
That's
Okay.
really-
And I'm going to show you, because y'all only talked about reflections and rotations and stuff over the axis.
But it's slide.
So either y'all did one, or that's the translation.
Oh.
So if you reflected it over the y-axis or you reflected it over the x-axis, but it's not actually being reflected over one of those. And we're gonna look at another one and see if you can figure out maybe where that reflection is happening, okay? So get one more and see if we can find it. If not, we'll talk about it. Okay, so now open your little booklet and we're gonna look at another one. Okay, so we're given a line to start with. Once again, they just gave us a blank table. Okay, so this blank table is going to represent our function f of x. Okay, I'm going to label all this one pink. Okay, and that's going to represent this original line that they have here for us. Okay, now before we can start finding the inverse, we've got to get some coordinates down.
Mhm.
Okay, luckily they've graphed it for us. So let's find some coordinates that line perfectly goes through.
-3, 1.
-3, 1,
At the 0, 2.
okay? -3, +1, 0, 2, 3, 3, perfect. And what I'm noticing is it has a slope of 1/3, 1/3, okay? So if I continued it one more time, because I don't see any more points on here, it would be 6, 4. Just so we can fill up our table. Okay, so now that we have that, that's really easy to come up with those coordinates if we have a graph, okay? So now we can just simply find the inverse, okay? Well, this time they just wrote inverse, but we know that there's a symbol for the inverse.
F of -1. But negative.
Perfect. F of -1 of x,
Thank you.
okay? So
Okay.
because we learned it in this first step up here, we can just simply switch our x and y's, right? What is the inverse of -3, 1?
1 with negative
1, -3. What's the inverse of 0, 2?
2, 0,
2, 0.
3,
3, 3. Interesting. So we're going to see now what that looks like graphically when you have the same x and y.
4, 6.
4, 6. Perfect.
So 3, 3, is it gonna be like whether they meet?
That is exactly what's going to happen.
And then that's why they.
But we know that that's not the big takeaway we're getting from it. These two will intersect, but that's not what it wants us to notice, because it says, what do you notice about the graphs? Okay, so I want y'all to see if y'all can find something else in common with the first one we did. So let's graph those coordinates and see what it looks like. So I have +1, -3. So that's down there. I have 2, 0. So that's right on the x-axis. 3, 3. It's going to intersect, like Kai said. And then 4, 6. So it's going to go off my graph and it's going to kind of go through that little line up there off the graph.
Okay.
All right, so now I'm going to connect all those lines. And let me make it a little thicker so you can see on camera.
Is me?
Yes, sir.
time I see your constant function thing up there, I think of the first episode of Winter Soldier. And whenever he's going through the war, or whatever.
I look at it, I just see that.
That's like a desert. That's at the Grand Canyon.
What it's showing you is that a constant function is just a function that has a horizontal line. So like
They're playing golf.
a line connecting.
'Cause I've
No,
always thought that.
they're like land surveyors.
Oh, it's tightrope ball.
No, they're land surveyors. Yeah, that one, absolute value. We've kind of got to quadratic, but we haven't really got to quadratic. We'll get to exponential next week.
What is it?
Chicken and cheese.
Why are they burning their-
Okay, so we're looking at this one. We see that both of them intersect, okay? The original with its inverse, okay? But that's not really what we want to get taken away, because once we get into these bigger functions, that's really not what its inverse looks like, okay? We did kind of notice maybe there was some sort of reflection, okay? So look between the one we just did and the one we did a second ago. What do you notice, Ava?
Like where it intersects, it's like I think it's called the center point, like where like it'll rotate and match up.
Okay, so that's exactly what's happening. This is the point at which they're being reflected or rotated or transforming around. Okay, okay. I don't remember what the center point's called. Not epicenter, that's triangles.
I think we just called it the center.
I think we did call it
Center point, okay.
They're like, I feel like equal.
What's equal?
Like you can flip them over and they'll. Like, they're the
Symmetrical?
same. Yeah.
They are symmetrical, perfect.
You know what I'm talking
Okay, so they are being reflected and they are symmetrical. Okay, but the only thing that y'all really haven't got to, the only thing y'all have ever discussed before now is that they reflect over an axis. These aren't being reflected over an axis, right? Okay, they're both taking place in a similar place. So let me get y'all the rest of the way. So what's happening is they, write this down, are
about?
symmetrical
Symmetrical.
to
To
the line
the line.
y equals x.
Y.
Okay, now we're not going to panic because I'm going to explain. Okay, so what the heck does that mean? Well, y'all got everything up until this part right here. Okay, so instead of them being reflected over an axis, they're actually being reflected over a line, okay, that we don't see. Okay, but this is actually another parent function. So we talked about one of the parent functions last week. Y equals absolute value of x. What did it form? A V, okay. Well, y equals x is another parent function. It's just a straight line. So let's see how they got that straight line, okay? So we know that this line right here is in slope intercept form because it's solved for y. If a line is in slope intercept form, then I know that if I look at my x, that the number paired with the x is my slope. Okay, well, there's not a number here, but how many x's do I have? I have one. So even though it's not there, you don't have to write it, but that's one x. So the number paired with my x is my slope. So what's my slope? 1. Okay. Now I know that the number all by itself is my y-intercept. Do I have a number by itself? No, there's nothing there. So we could have easily just put +0, which wouldn't change. It wouldn't change the outcome of my equation. So this number over here all by itself is my what? So where is it crossing through my y-axis? At 0. Okay, so let's draw this line and see what happens on my graph. Okay, so I'm going to start at the origin. I'm going to graph that point. Okay, so that's my starting point. What's my slope? 1. So I'm going to go up 1, over 1, and graph it.
Right in the middle of them.
And it crosses right through that point again. So that's that point Ava said was our center point, where it's being reflected over in this particular function. Okay, And then I'm just gonna keep going, and you can see that that line forms, or that equation forms that straight line.
Are you gonna draw a line?
Yes,
Okay.
okay, which is just like our little picture here, look. It formed the same kind of line, didn't it? Okay. Oops, I kind of made my thing blur. All right, so now I'm gonna connect all those lines, or I'm sorry, those dots. And now you can see that our original function, which on mine is the pink line, and the inverse, which is the green line, is reflected over, it's symmetrical to y equals x. Okay, every single inverse function will always be symmetrical to and reflected over that line. Okay, you could do the same thing with the first one we did. You don't have to draw this one, but look at mine. I can do it quick. Zoom in on here. And I go to the origin here. You can see, once again, it's perfectly symmetrical to cross that line. Okay, that's how every inverse function will always be.
So it will always be 3, 3.
Not necessarily, because look, this one doesn't go through 3, 3,
Yeah.
but it is crossing through that point.
Will it always be like, just like always be one?
For this line, not for the necessarily the functions you have, but for the line that it's symmetrical over, it will always be 1 over 1.
Will it be in other boxes?
Say it again.
Like the.
Yeah, or we'll look at more. We'll look at one with absolute value here in a second, and it's like, it's not more complicated, but it's a V shape instead of a line. Okay, last way, sometimes we may not get coordinates, we may not get a graph, we'll get the equation, which if we have the equation, we could graph it and we could make a table of it if we wanted to. But there's another way you can find the inverse algebraically, okay? So this is steps for creating the equation of an inverse function. So you can see here's my original function, f of x equals 2x plus 3. And then you can see here's the little symbol. What does this mean? It means the inverse, right? That means it's the inverse. So this is the equation for the inverse. So if I graphed both of these, they would, in this case, they're going to intersect, but they're going to be reflected over that y equals x. Okay, but I'm going to show you how to get from here to here. Okay, and all these steps we've done before. So good news, it's nothing new. All right, so people at home, here are the steps. You need to take a second, maybe just take a picture of your screen so you don't get behind. But here are the 4 steps for writing the inverse function. Okay. And we're going to do 2 examples. The first one I'm going to do where I'm really going to heavily walk you through it. And the second one, y'all are going to tell me every step. But luckily you have them all written out here. Okay, so split your little section in half so we don't get them messy. All right, but here's our first example. So we're given this equation. So what does the very first step tell us to do? Okay, so I'm looking here and I'm just going to change this to y equals 4x minus 2. Okay, that's step 1. Okay, so there, okay, step 2. After you've written that, there's that same pattern like we did up at the very beginning. It's that idea of switching your x's and your y's. So I'm going to do that. So now it's going to be x equals 4y minus 2.
Why did I do that?
So now it's just a quicker way to find that inverse. Okay, then we do what we've done 1,000 times before. We're simply going to solve it for y.
Keep them around 4 and put y and c.
Correct.
Okay, so we're on step 3 now. So you can see how that's why I'm labeling these and circling them. Those are the steps. All right, step 3, we're solving for y. Okay, now if I'm solving for y, what is the goal? What are we trying to do if we're solving for a variable? To get it by itself, okay? So in order to do that, you have to do the inverse. Okay, so when I'm solving for y, I start with a term that is Furthest away, I'm gonna use orange. Okay, so furthest away is -2. How do I get rid of -2? Add 2. If I do it to one side, gotta do it to the other side. Do I need to zoom in or can y'all see? Okay, or what happens to my 2's?
Cancel out.
They cancel out. Now, this is a part where a lot of people mess up. X plus 2 simplifies to
2x.
X plus 2. Why is it not 2x? You cannot add or subtract unlike terms. Okay, if this 2 had an X with it, you could combine them, but it doesn't. So it stays X plus 2. All right, and what's left on the other side of my equal sign? 4y. All right, am I done? Nope, y is not by itself yet. How do I get rid of that? Times 4. I divide it by 4. If I do it to one side, I have to do it to everything on the other side. It's really not because you have calculator. So everyone get your calculator right now. This is the part where I don't want us to be afraid of this step. Okay, now, first things first, a lot of people get to here and they say X divided by 4. What's happening? Okay, nope. This is just 1x divided by 4. You just take the numbers. Don't look at the variables yet. Okay, so what am I actually dividing? 1 divided by 4. So everyone in your calculator, 1 divided by 4, enter. All right, we never want a decimal when we're writing equations. So how do I take that decimal and change it to a fraction? That would change it to a percentage. It would be 1/4, but how did you get that? How can our calculator tell us that? We hit math. Hit math, it's right under the green button. And then the very first thing says frac, that's fraction. Hit enter, enter. And what is it? 1/4, okay? So I'm just gonna do 1/4, and then I'm gonna bring down my X. All right, the next one, what am I dividing? Okay, now really quickly, I'm gonna say it here, but it's obvious, but in other times it's where we get messed up. But this is a +2 divided by a +4. That really doesn't change anything for us, but in the future, we're gonna be working with negatives and positives mixed together, so you gotta pay attention to those. Okay, so in my calculator, I'm gonna do 2 divided by 4, 0.5, but I don't wanna leave it as a decimal. How do I change it? Math, frac, enter. What do I get? Okay, it's a +1/2, so I'm gonna do +1/2 equals y, because my 4 is canceled.
Can't you see that by like inverting all the stuff on the original equation?
You can do that with the slope every time, but sometimes the y-intercept doesn't always work that way.
That would be a lot faster.
It would be a lot
If it
faster.
worked all the time.
Okay, so there's that. We got y by itself. So now we can go on to step 4. And what does step 4 tell us to do? Replace y with the little inverse symbol, okay? And listen, if you want to just rewrite it and tag it on at the end, that's correct. I personally like to put my function at the beginning of the equation just because that's what I've always done. So I like to write it like this and then write out the rest of my equation. But it doesn't matter, it's correct whichever side you put it on. Okay, I'm not going to count it wrong.
So now we do it ourselves.
Yeah, but we're going to do it together. You are just going to tell me what steps to take. Okay? All right, give me a thumbs up if we're ready to go on to the second example. Look it up. All right, example 2. So here's our original function. What's my first step?
Write it down.
Okay, write what down?
The whole thing.
Replace f of x.
Replace f of x with y. So I am rewriting it, but I have to change that one thing first. Okay? So then I have to do what?
Switch Y to
Switch y and x. Okay? All the numbers and coefficients and stuff stay paired with
wait,
in the same spot.
why'd you switch it to Y and switch it back to X?
If you had to.
So we changed this to a y because it's easier to work with a y than f of x.
Who X equals what?
F of x and y are essentially the same thing. Okay? And then you have to switch them because we're doing the inverse of it. Okay? So now that we've switched that, what are we doing? What's next?
Solve for
We're solving for y. Okay. How do I do it? First step,
start with the term first.
start with that term that is furthest away. So I'm gonna have to subtract 5. Does cancel out. Got to do it to the other side. It is just x minus 5. Okay? Equals negative 3y. Good. Am I done? No, why not?
You gotta
Yeah,
divide
the Y by itself.
negative
Got to get the y by itself, and I do that by doing what, Ava?
three. Y by negative three.
Divide by negative 3, so that's times negative 3. Kobe. So I have to divide by negative 3. Who's asleep?
Yeah.
Wake up, huh?
All right, so I'm dividing by negative 3, then what do I have to do?
Divide by
Do-
the
do-
whole
do it to the
side.
whole thing.
The whole thing.
Those won't cancel out.
These,
Teacher, I have a question.
Yeah.
yes, ma'am.
So whenever we were doing this way back, man, we would draw a line and then just draw one negative.
Yeah.
Are we still doing the same thing like that?
Yeah, the reason I quit doing that is because when I do it just once like that, a lot of people just think you do the first number divided by negative 3.
Okay.
So I've started showing it that I'm doing that to both.
Okay,
Terms.
right, no,
It means the same thing. If you wrote that, it's not wrong. It's just when you do it, you have to remember that you're dividing everything by
I mean,
negative
that
3.
would make more sense.
Yeah. Okay, so this is where it kind of gets confusing, but we know how to do it because we have calculators that can do all the work for us. So starting from the left, what am I doing here?
One divided by negative three.
Positive 1 divided by negative 3. So let's do that in our calculators. 1 divided by negative 3, but we don't want it as a decimal. We want it as a fraction. So how do I do that? Math, fraction.
1/3, isn't it? Negative 1/3.
Negative 1/3. Negative 1/3, and then I have to bring down my variable. Don't forget your variable. Okay, here's the one where it's really important. What am I simplifying next?
5/3.
That's what it will be, but what am I having? For the people who may be confused on it, what do they have to make sure they do?
Divide.
It's a negative 5 divided by a negative 3. So we know that if we have a negative divided by a negative, it's going to become positive. So you got to be careful. That's why I was emphasizing it. Okay. So negative 5 divided by negative 3. Do we want to leave it as a decimal? So what do I do? Math, enter, and it's a positive 5/3. So what some of y'all see is like, oh, it's subtract. So I move that subtraction there. Nope. Since you did a negative divided by a negative, it becomes positive. All right, what happens to my negative 3s? And I'm left with, all right, almost done. What do I have left to do?
Gotta replace the Y.
I just got to change it with a little inverse symbol. So really nothing is new. The only new step is step 2. Everything else we've done before.
Okay,
This is
so,
like, sorry, go ahead.
so pretty much it's just like, you're just kind of like changing the signs on step when you're doing, or when you're solving for y.
Correct.
Because they're pretty much the same.
Yeah, because it already starts out solve for y.
Yeah.
So we can't solve for y if it's already solved for y. So you switch it, that creates the inverse, then you solve it for y again. Okay, and then that gives you the inverse equation. Now, I want y'all, this isn't something it wanted us to do, but I just want you to see that once again, if I were to take this information and graph it, which you can also do this in your calculator, which I'll show you how to do that as well. Okay, so our original equation, I'm doing the second one, y equals negative 3x plus 5. Okay, there's my line. Yep, that adds up. Negative slope. Y-intercept is at positive 5. Okay. The next one, the y equals negative 1/3 x plus 5/3. All right, look, yes, they didn't intersect, but that's not what we want to focus on. What is true about all inverse functions? They are what? Symmetrical across, the symmetrical reflection across y equals x. Okay, look, so I'm just going to do y equals x down here. Are they symmetrical across that line?
Yes.
Yes, they are. I could fold that function over that line and then they would be symmetrical. Okay, so there is that. Okay, so you leave that out and we're going to review absolute value functions and incorporate that in with what we now know about inverse functions. Okay, it's fine. We're going to love it. Okay. Huh?
Right now.
Right now. No, we're not taking a break.
Do we get a break?
You will get a break. Yes.
What time is it?
8:40.
That's how bring you.
No. All right. So I also passed out this graph paper. If you have graph paper at home, you can get that out. If not, just get another sheet of paper. All of my graphs that I have are all to go to 9. Okay, so we are going to look at absolute value functions and then we're going to do an inverse of an absolute value function. So this was like a week ago when we did it, so we're gonna ease our way back in. Okay, so first function was the basic absolute value function, f of x equals the absolute value of x. Now, here's what I was saying earlier about tables being our best friend. You may get on a test and you see that function and you think in your head, I do not remember absolute value functions. I know we talked about it and I remember it, but I can't remember what the graph looks like. Well, this is where tables become your best friend. So right underneath this, I want you to draw a little X, Y table. You can do this with every equation ever, including like really big scary ones that have like square roots and exponents and all that jazz. Okay, just to show you how completely on your own this can be, the x values that you choose can be any x values you choose. I like to do some negatives. I always do 0, and then I do some positives, okay? So, Kai, give me a negative number.
-7.
Okay, and also I like to choose smaller numbers because those are easier to work with. Okay, so -7, okay, now someone give me one between 0 and -7. -2, all right, and I'll do -1. And then I'll do 0, and then I'll do all those positives. Okay, so do y'all agree that those were completely random x values that we made up? Personally, I like to do like, if I don't need a big graph, I do -2, -1, 0, 1, 2 every single time. But if I'm realizing it's not really working for me, then I'll do -3, -2, -1, 0, 1, 2, 3. Okay, so here we go. Now, I have x values, I have an equation. What do? I plug it in. So we know the absolute value talks about distance from 0, okay? And we know distance always is positive, okay? So what's the distance from -7 to 0? 7. What's the distance of -2 to 0? What about -1? What What about 0?
0,
What about positive 1?
-1.
No,
What?
positive 1, because it's distance. Because it's distance from 0, and distance always is positive. That's why people think, oh, absolute value, it just makes the number positive. Yes, it does, but it's because it's talking about distance. Okay?
1 point.
How far away is 2 from 0? 2, and how far away is 7? 7. Okay, so now that you've created a table, you don't even have to remember what the absolute value function looked like or anything. You can literally just graph these coordinates and it'll form it for you. So graph them. I'm gonna go to -7. I'm gonna go to 1, 2, 3, 4, 5, 6, 7. Okay, now go to -2, 2, -1, 1, 0.
Whoa. Oh, that's great.
No. That's crazy, dude.
Wild.
Frisbee, I was snapping Gage in the car yesterday. I was like, tell Frisbee I said hi.
You didn't tell me.
Nope.
He does that to me every day. You should tell her I said hi. She goes, no. They just made it. What you doing, Mom?
Some dude was like trying to fight Gage.
I know, that made me mad.
His name is like.
No, it's
So I'm getting some screenshots. All right, now we talked about this last week when we made all our observations. We discovered that anytime we are talking about an absolute value function, what is it always going to form? A V shape. So you can just, yes,
Can
ma'am.
you add a dot?
I went all the way to 7.
she went to 0.
Alright, cause I don't have one of those.
Did you
You
do
did
-7,
0.
-2, -1, 0, 1, 2, and 7?
Yeah, but I don't have the -1. Oh.
Because she got plotted.
Do you have this in your table?
Yeah,
Then you got to plot.
Where did you plot it?
no, I don't.
All right, so then you're going to take all those points and we're just going to connect them. But don't draw, make it a V. Don't keep your line going past it.
I'm ready for tribal council today.
Oh my gosh, next Friday, I'm gonna be here.
You literally had 2 days off this week.
I know, but.
Yeah, but we didn't get to stay here and hang out with you for you.
It's true.
And I gotta get caught from
She was texting.
All right. So that is your basic absolute value function. That's what every single absolute value function that it is built off of. Okay. One thing I want us to understand though, where is its vertex? Who knows what the vertex is? The meeting point. Where's it at? It's a 0, 0. That's important because when we start talking about the translations, the vertex is the thing that's moving. Okay. Now, let's do a second one. Okay. All right. So go to the second graph. Now we're going to do a translation. I'm sorry. We have f of x equals the absolute value of x minus 1. Okay, so we talked about this real quick. There's an operation taking place this time. It's not just our absolute value of x. Where is the operation taking place? It's, well, just like, where is this subtraction problem happening within my equation? It's happening inside the absolute value. Write that down. Inside abs value. We talked about this. Okay, so in your head, you're thinking, oh, I remember this. Something happens when the operation is inside and when the operation is outside, but I can't remember it. Oh no, I forgot how to do it. But if we forget, what's the really easy thing we can create? A table. Okay, so let's see. Yes, but it's not going to be the same y values because it's a different function. We can use the same x values. We can use less. I'll do -2, -1, 0, 1, and 2. This is what my math teacher always used. He used those 5 numbers every time.
Hey, you had a guy for.
Yes, Mr. Nelson, he was the best teacher.
No, you're the best teacher.
Thanks. He's the reason I became a teacher. All right, so I have x values. I have a function. What can I do? Plug it in. Okay, so I have -2 minus 1. Use your calculator if you don't know. It's your best friend. -2 minus 1 is -3. The absolute value of -3 is +3.
Whoa,
Wait, why'd you, what?
because, the absolute value.
But look, if you couldn't do that, you could have done it in your calculator. Go to math, go over to number, and it says abs.
Abs.
So I could do, the next one is -1. I could do -1 minus 1, and I get what? 2. Okay, then I can go back, I can hit second enter, and it types it all over again. I can change it to
-1.
0.
-1.
0 minus 1, it would be,
Negative.
it'd be -1, but it was absolute value, so it became +1.
So, can you explain how you did it the first time? Cause
Math,
yeah,
like how to find it on a calculator.
no, like how to do it, like, without using the calculator.
Yeah, once we graph it, I'm gonna explain that. Okay, and then we'll do some where we start by just doing it and then proving it
No,
on the
I'm just
table.
talking about on the table. Can you just like explain how you did it?
Okay, so I take my X value of -2 and I just plug it in. So that's -2 minus 1, which is -3. And then I have the absolute value of -3, so that would be +3. And so that just becomes my coordinate.
I just don't understand. I don't know how it happens. I was just,
That's what we've done. That's what we did here too.
like it's 3 away from 0?
Yeah.
Oh, okay.
Yeah, when it's
You
just
never
like,
do that, that equation.
yeah, you're just plugging it into your equation. Okay, so then we have 1. So if our X value is 1, 1 minus 1 is, how far away is 0 from 0? 0. Okay, then we have 2, so we plug that in. What's 2 minus 1? 1. What's the absolute value of 1? 1. All right, so we have some coordinates. Let's graph them. So I have -2, +3. I have -1, +2. 0, 1. 1, 0. And 2, 1. All right, once again, it formed a what? Well, if we continued, it would form that V shape. This one is more of a check mark just because we didn't have more coordinates, but if we continued, it would. All right, now what do you notice? Because on my other one, my vertex was where?
At 0.
At 0. Where's my vertex now?
It's at 1, 0, because on the inside of the absolute value, it's 1.
Okay, now our vertex moved. What did my vertex move along?
Like that.
Which axis? The X. So we determined this last week, but it's been a minute. We might have forgotten these rules, but luckily we had this table to use in case we forgot. If we have an operation that's happening inside the absolute value, it moves along, the vertex will be moving along the x-axis. Well, this says -1, so why is the vertex at +1? Well, you just do the opposite of what that symbol is. Because when we're measuring distance, we subtract. So you're just subtracting it from a +1, okay? Now, what if this said x plus 2? Where would my vertex be?
Left.
It would go to -2. What if it was x minus 9? It'd be at +9, okay? What if it was an x plus 3? It would go to -3, okay? So it's just moving along this axis, okay?
Which one was it when it was like up and down?
That's one we're gonna look at next. Okay, so now we have a function that looks like this. F of x equals the absolute value of x plus 3 on the outside. Okay, I see that it's an absolute value. I know it's gonna be in what shape? What's my graph gonna look like? I mean, it's gonna be V-shaped. Okay. All right, but there is a transformation taking place, but I can't remember what that rule is. I can't remember what it means if it's outside or if it's inside or if I did the opposite or not. So if I can't remember, what can I do? I can make a table, but before I do this, let's just try to see if we can graph it first and let's see if the table matches it. Okay, so I just remember that if it's on the outside of it, It kind of works like a y-intercept on a slope, like in slope-intercept form. So this says +3. So if it is +3 and it's on the outside of the absolute value, what's it going to move along this time?
Y-axis.
The y-axis. And if it's a +3, where's it going to go?
It's gonna be 0, 3.
0, 3. It's going to go up 3. It actually does what it says it's going to do. Okay. And then this x works like this, like the slope of a regular line. What's the number in front of my x?
1.
1. Okay. That works like the slope. So I'm going to go up 1 over 1. And I'm going to form this right side of my v.
That's easy.
Okay. Now I know that's the absolute value. So what's it going to form? A v. So it's not just going to keep forming a line. So I'm going to go back to my 3 and I'm just going to form my v the other way. Up 1 over 1. Form that v shape.
Will it ever be like on the y-axis, but it'll go that way or something?
Mhm.
Yeah. Does that make-
We're going to do that in just a second when we do the inverse.
Okay. I understand how that works.
Okay, so there is my absolute value. So when it's on the outside of the absolute value, it goes up and down and you go based off whatever the operation is that you're working with. Now, say you didn't remember that rule. Your best friend is what? A table. A calculator too, if you know how to do this on the calculator. I can show you how to do that in just a second. Okay, so I always like to use -2, -1, 0, 1, 2. I like to use those x values. Doesn't matter which ones you choose. Okay, let's try it. What's the absolute value of -2? It's 2. And then I do +3. 5. My y value would be 5. All right, let's go to my graph. -2, 1, 2, 3, 4, 5. Did that follow my function? It did. Let's go to the next one. What's the absolute value of -1?
4.
It'd be 1 plus 3 would be 4. So let's look on my graph. I go to -1. I go up 1, 2, 3, 4. It worked. Okay. What do you think the y value will be for 0? 3. What do you think the y value will be for 1? What about 2? 5. Okay. And look, so either way you can do it. You can draw your graph first and check it with the table, or if you're not sure what those rules are, do a table, then draw the graph. It doesn't matter. Okay. Your calculator can also do it as long as your original function is solved for y, which it is. It's set equal to f of x. You can just go to this button up here. It says y equals. Okay, that's like an equation. Click on it and then just type in your thing. It was the absolute value. So math, numbers, make an x. The x is right beside the green button right here. It says x. And then go on the outside of my absolute value and do +3.
Wait, where's the X at?
Right to the right of the green button. Has a bunch of symbols on it. X is the first one. See it? It's right here.
So what do you do after that?
So it should look like the absolute value of x, and then I just arrow over to get on the outside of it, and I do +3. Okay, so is that what it looks like in there? Okay, so now you have your equation, and you just click on graph over there at the top right-hand corner, and boom, it draws you an absolute value function. And you can see the vertex at +3.
I'm just kind of air. It had the ground, it went kind of air.
What that means, you did something wrong. Yeah, I'm here. That's why it's an error. My y-axis is like,
All righty.
break?
No.
Break? No. No breaks.
Next. This one we didn't actually talk about last week, so I think you'll pick up on it easily. It's not that hard. Okay, now we have the absolute value of 2x. Okay, so there's no addition and subtraction operations happening to it, but now there is a number paired with my x. Okay, so no, that would be if there was a negative on the outside of the absolute value.
Doesn't do that.
It does do that, yes. Okay, now This is very similar to this first one that we started with. Now, there's no addition or subtraction operation happening, so it's still gonna start at the origin. And if I didn't know that for sure, what could I have created? A table, okay? But I know it starts at the origin because there's no addition or subtraction happening within the absolute value or outside of it. But this time, there's a number in front of my x, and we know this x works, the number in front of the x works as the slope. Okay, so in this case, the slope isn't 1. It's not going to have the same increase and decrease like these other v's. This time the slope is a larger number. Okay, so I'm going to start the vertex. Instead of going up 1 over 1 the whole time, what am I going to do? Up 2 over 1. So let's try that. Let's just graph it and see what happens. Up 2 over 1, up 2 over 1. Okay, I know because it's an absolute value, it has to form a V, so I can just do the same thing in the opposite direction. Up 2 over 1 to form that V shape. What happened to my V because my slope changed?
It got in wider.
It totters. It's a skinnier V. You could say it's a steeper slope. All of those are correct. So if my slope continued to become a larger number, what do you think my function would become? It would just keep getting skinnier. What if I had a fraction slope? What do you think it would do? It would get bigger. How? Like wider. Okay.
Big boy.
All right. So 2 more and then we'll take a break. I promise. Okay.
How many are we at?
2 more.
Total 6.
Okay. And also, what could you have drawn if you didn't remember that rule of when there's a number in front of your slope? You could draw a table. Okay, now here we go. There's one more easy one, and then we're going to do an inverse one. Okay, so prepare yourself mentally. It's not hard, but you have to remember all the rules. Okay, so next one, f of x equals the absolute value. And again, I like to make those really exaggerated so they don't look like ones. Okay, so the absolute value of 1/2 x, close my absolute value, plus 3 on the outside. Okay, so this one not only has a dilation because it's growing my function, but it also has a translation, which it's moving the vertex. Okay, so let's see if we can remember the rules first. If we can't, we'll go to a table. Okay. Just know I didn't know these rules. I kind of knew of them, but I had to draw a table every single time I did any function because it was just a lot to remember. Okay. So if you don't remember all the rules, that's okay. That's why tables are our best friends. Okay. So first things first, I have a translation. I have plus 3. Okay. If it is on the outside of the absolute value, where is my vertex moving? Down and up. Across the y, okay? So it's moving along my y-axis. Where's the vertex going to go? It's going to go to positive 3, okay? When it's on the outside, you do exactly what the operation says. Yes, sir.
It's gonna be like that.
It is. Okay, kinda, but your V is not right.
Oh.
V is not exactly right. Okay, now that's where the vertex will be. So you can go ahead and graph that point. Okay, it's not moving anymore. We're gonna have 2 translations in a second.
I see now.
If there was a minus or a plus on the inside, then it would move again, but it's not. Now we have a fraction in front of our x. We know that this x works like the slope. So what is my slope this time? Up 1 over 2. I'm going to start at my vertex. I'm going to go up 1 over 2. Up 1 over 2. What do you notice about the slope of that line?
Getting wide.
It's wider, okay? There is an absolute value in this function, so I know that it's going to form a what? V. So I can start back at my vertex and I can go the opposite way and form my V. Okay, so our prediction was correct.
Yeah.
Oops, I messed that up, but y'all can see it. Okay, now, if you could not remember that function, thankfully we have calculators.
Oh, yeah.
The best friend.
It's our best friend, okay?
We got too many best friends.
Can you?
No, you can have more than that.
Okay, you could have easily you could also graph it always and check your work and see if it looks similar. Okay, but I can look here, it's -2 is my first X value. I'm ignoring all my other X values. Okay, y'all pay attention because this is like the basic understanding of a function. So this is saying my input is -2, so that becomes my X. Well, everywhere I see an X in my function, I'm going to substitute it with -2. So in my calculator, I have the absolute value of, I'm putting it in parentheses, 1/2 times -2, close parentheses, get out of my absolute value, and I'm going to do +3, right? Enter. What do I get? 4. Okay, now look, let's see if that's on my graph. I'm going to start at my origin. I'm going to go to -2, up 1, 2, 3, 4. Is that a coordinate?
It is.
It is. Oh my gosh, it works. All right, now instead of having to type that all over again, you can just arrow up and highlight it and hit enter, and it will bring it again. I can just arrow over and change that to a 1. And it is what? 3.5. Okay, now that one would have been hard to graph, but we can still see if we go to it, -1, and it's right there at 3.5. Yep. Okay, then at 0, I'm just going to change this to 0. Oh, 0 would be 3. Okay, then I'm going to do it again, and I get 3.5 and then 4. Okay, so lots of ways you can approach it. You can remember the rules of it. You can graph it. You can create a table. There's so many things, but all of them are connected together.
Yes.
Okay, last one, and it's a doozy, but we can do it. I believe in you. Are you ready for it? Then we'll take a break, I promise.
Yes.
Okay. F of X equals the absolute value of 3x plus 2, close the absolute value, minus 4. All right. Lots going on here.
So it's gonna be like this, right?
We're just doing it all.
No,
No,
it
it's
will,
gonna be down
it's
at
still
the
going to be
bottom.
up.
It's gonna be at the bottom line, a negative.
All right, now there are two translations happening. Okay, first one, there's one on the outside and there's one on the inside. All right, then we also have a dilation because there's a number in front of our X. Okay, lots going on here. But if we could not, our minds are blank, empty, nothing's going on. What could we do to draw this graph? We could create a table, okay? But we're going to try to remember the rules first and then check it with a table. Okay, so first things first, it doesn't matter which translation you start with. I'll start with the one on the inside, just so we read it from left to right. But you do have to start with these before you start with this, okay? You have to get your vertex done first. Okay, so this is inside. So what axis am I moving across? The X, okay? It says +2, but we know when it's inside, it's actually the negative, okay? So my vertex is right here at -2, but don't graph it yet because there's another translation where that vertex has to go, okay? When it's outside, what way is it moving? Whatever it says. So where's it going? It's going down 4. So I'm going to -2, -4, and that's my vertex. Okay, now we have this dilation. We know that this number paired with my X acts like the slope. If you can't remember that, just label it. What is my slope? 3. So since it's a whole number, it's understood to be over 1. So I'm going to start at that vertex, and what am I going to do? Up 3 over 1. Okay, look, that's just gonna form a line, but I know since there's an absolute value, it actually has to form a
V.
V shape, okay? So I'm gonna go, start back at my vertex, I'm gonna go the opposite way and form that V. 1, 2, 3.
I need to check on my brother. I think he might have.
Okay, now connect it and you have your V. What do you notice because there was a 3 in front of my V? What do you notice about your V shape? It's skinny, good. The larger the number is in front of your X, the skinnier. The smaller it is, the wider. Okay, there is our original function. That's our f of X. We did it. Okay, now we're gonna do the inverse.
Oh,
The
no.
easiest way to do an inverse is from a table. Don't y'all think the table was way easier than solving it algebraically?
Yeah.
Yes, okay, I agree. So let's get some coordinates from our original function.
Are you ready?
All right, so create a table. We're gonna label it f of X.
Okay.
So we're just gonna redraw it.
Yeah, I'm just writing it right here. Okay, let's start with negative. I'm gonna just do the coordinates that are on here because that's easier. That we already graphed. So my X was -5.
Can you just graph it the other way? You know, like you couldn't go like down 3 over 1, or however we did it. Like on this one, down 3 over 1.
It won't work like that. That's good thought. But you're close, but it's not necessarily like that because it's not reflected over its vertex. It's reflected over that y equals X. So it's not exactly there. Okay, now when X, can you capitalize? Sure. If you want. So when my X was -5, what was my Y?
5.
+5. Okay. Next one I see is -4. What was the Y value?
2.
2. So I got -4, +2. All right, the next X is -3. What's the Y?
-1.
So -3, -1. Okay, the next X I have is -2. What's the Y?
-4.
-4. Then I have -1. What's the Y?
Oh, -1.
-1, -1. So what do you think is going to happen on that inverse? At -1, -1.
So it's gonna cross.
I bet it's going to cross right there. Keep going a little bit further. Let's get let's get 0 and some positives. So what happens at 0? 2, and then 1, 5. That should be enough.
Yes.
So you just went through.
Yeah, it's -1, -1, 0, 2, and 1, 5. Yeah, I just graphed those coordinates that it went through. Okay, if we would have worked it backwards, we would have came up with these coordinates first, plugged them into our equation, and that would have been the outputs we got.
So now
That's the only one, the next one.
Huh?
It's like.
Yeah, this is the only inverse we're doing because it's a lot of steps. Okay, now the easiest way to get the inverse is now to just take this table and do what with it? Flip it. Okay, so I'm going to come over here in this little blank space and I'm going to do the inverse. Okay, so here's all my X's and my Y's. So -5, +5 becomes +5, -5, right?
Yes.
I just switched them, right? Okay, -4, +2 becomes
2, -.
2, -4. Yep, don't switch their signs, just switch the numbers. -3, -1 becomes -1, -3. -4, I'm sorry, -2, -4 becomes, good. -1, -1 is 0, 2 becomes, and then 1, 5 becomes 5, 1. All right, now take a second and graph that. Graph those coordinates. Be real careful with it, especially if you're using a pen. I don't think any of you are using pens. Okay, good. A lot of people used pens in my class yesterday and that kind of messed it up. Okay, 5, -5, 2, -4.
Wow. Bless you.
God bless you.
What about Elvis Presley?
I'm sorry, what?
Elvis
Elvis Presley.
Michael Jackson's not.
They're pretty stupid now.
You know, I don't
Elvis
appreciate
Presley.
bullying.
I don't appreciate you disrespecting Elvis Presley.
But aren't you disrespecting him now, saying
I'm making fun of him.
by disrespecting?
Yes, because he disrespected first. So at this point, it doesn't matter.
So really are disrespecting each other.
No,
disrespecting
he's already
Elvis Presley.
disrespected at this point. It doesn't matter.
Cliff, do you care if I use your orange powder real quick?
There's no way to do that.
Oh, I didn't mind waving. Dang.
Make us look good.
What?
Elvis Presley.
No, I already forgot.
Yay, y'all did transformations, translations, dilations, and it's in verse.
And that reverend saying,
That's 4 lessons in the book and we finished it.
Let's
Do
go.
that.
All right,
We got a break.
you're taking a break. Now listen,
Let
me pause.
I don't think he's dead. He just responded to my snap.